So for the first part, which will be about inductive reactance, which is basically the reaction of an inductor to the changing value of the current. The symbol is XL, which is basically the reactance of an inductor, and it is measured in ohms. Now this is the formula given, which is 2 pi multiplied by the frequency multiplied by the inductor. So here we have an example. A 50 millihenry inductor is in series with a 10 volt AC source with a frequency of 45 Hz. Calculate the inductive reactance. Now what we have given here is the inductor, the voltage and the frequency, and what we want to find is the reactance of an inductor. So the formula is XL equals 2 pi FL. Now substituting the values, you will get 2 pi multiplied by 45 multiplied by 50 to the 10 to the power minus 3, which should be 9 over 2 pi ohms. Okay, now for the second part, which is capacitive reactance, which is basically the same point, is just the reaction of a capacitor to the changing value of the current. So basically it's the same concept as the inductance, but this is using a capacitor. Now the capacitive reactance symbol is XC, so reactance of the capacitor, and it's measured in ohms. Now the formula as seen here is XC equals 1 over 2 pi multiplied by the frequency multiplied by the capacitor. Another example here, a 30 microfarad capacitor is in series with a 10 volt AC source with a frequency of 50 Hz. Calculate the capacitive reactance. What we have given here is the capacitor, the voltage and the frequency. What we want to find is the capacitive reactance. Now as you can see the formula here, substituting the values, 2 pi multiplied by 50 Hz multiplied by 30 multiplied by 10 to the minus 6 power minus 6, which should be basically 106.1 ohms.